So the new software, if you install, you're gonna have a new tab, so you can also keep the old version of the software. So I recommend everyone, because in our group we have two version. The old one we have been working on the previous project, so you can keep it, but um, it's just the matter of the format. You can change to use the new one, but it will affect. If it take a lot of time, you can just use both version at the same time. This is the maybe open a new file so it's easier to see. So this is the new user interface of the updated software. Um, and to start, let me introduce first to work with the program. You need to select what type of software you want to work with, ETAPS, SAFE, or SAP. So you click this button. You click this button and then you choose what software you want to work with. It's a bit different with the previous version when you select from the panel, but in this new version you select directly from here. So let's say I select ETAPS. Now I can work with ETAPS. If I select Safe, I can work with Safe. It's showing the icon of Shape here. Okay, come back to ETAPS. So the final user interface of the program will be looking like this. From now on, I will not change anymore. It's kind of fixed. So it has three major tools, modeling tools and analysis tools. It will relate. It will connect directly with ETAPS. Let's try to transfer and obtain the result from the programs. And these kind of tools, basically, I think you're already familiar with the sheets to show the all of these sheets in the Excel to control the tab in Excel. And these counts basically implement the KL counts into this to for convenience. So from now on, you don't need to use KL counts in a separate program because it's included in here already. It is similar to KL counts. It's nothing new here. And this is called design tools. Later during the example, I will show you. So basically, I separate between the design tools and the connection tools. Okay. So basically, this button here is now only to use to transfer and obtain the result from the program. In short, this panel here, in order to interact with ETAPS and SAP or SAFE, and here, this button here will mainly to do the design function with Excel. Okay, so three tools. So let's start with maybe let's start with the first example. Um, okay, let's talk about the first core function of the program first. The core function now is shown in this define. Okay, so the key function of the program, the key concept of the program now is interact with the CSI software through the keyword. So there's a lot of keywords here to help you to easy to actually communicate with the programs. So to use this, basically you just need to click one of the keywords here, and you can double click to have the keyword running on the Excel. Or if you want to choose many keyword, you can just select and click insert assign. Yeah, index assign. It will show you the keyword. So each of the keywords here will actually um, serve as a symbol to get some of the result from ETAPS. As right now I just talked about ETAP, but you can understand it will be the same thing for safe or SAP. As long as you choose this button, and then it will work with the program that you choose. Okay, let me show you one example. For example, I want to get the I want to get some information of the point through the program. The first thing I would do is I just from the empty spreadsheet I just double click I get out the point the index name. I put a point here, and then here is some properties of of the points. Let's say the point spring, the let's say XY coordinate. Okay, I just click here and insert a sign. So basically, this grammar showing you, okay, I will try to, first I need to have some point list. Then next I want to get some point coordinate. So that's what I do. So from the program, let's say this one is not easy to understand. The point usually we use with foundation. So let me open one foundation um, to show you an example. Okay, this is the safe happen. Okay, here, okay, you can see this is one of the foundation of Faber House. So I go to the bottom of the pie. So you can see the pie, the point um, has the spring assigned to it as well. So first I want to get I want to get the point list. Okay, and I select all the point, and let's go to back to the program. Maybe I put it side by side so it's easier to follow. So in order to get the information from the point, of course you will go to the footing. Okay, all of the function of the related to footing will be put in this panel. And let's say you want to get the point list. Um, okay, before you do any click into this button, I try to click save because there's some bugs I haven't been able to fix. You know, it has sometimes it when you click the button, it will hang the Excel if you don't click save. So please click save first before you do. Here I will try to get the point list. Then I will just select the point and then I get the point. Sorry, I just couldn't get the result. Somebody know why? Any guess?
This E-tab.
Yeah,
Yeah.
ETAP is select. So because you want to work with safe, right? So you have to from the program you have to click safe. Okay, and you have to make sure that this is the active in instant. So you have to click this button if it's not active. Okay, so now I can work with save already. I click save, and I get the point list again. Oh, okay. If you just choose one cell, it will show all of the point list in one cell and then separate by the semi-comma. But in order to get the point list in the column, you have to select two or more. So to get point list, oh sorry, have to select again, and you get point list. Oh sorry, I have select two. Select again and select two and get a point list. So I can be able to get the point list. So this is the unique name of the point list. And let's say I want to get the coordinate of this point list. I will select all the point and I click save again. And I want to get the point property. Okay, it will show me the coordinate of the point. Okay. Let's say I want to pull out more properties from this. I will try to add the spring in index here. Okay, and then I select the point again. I select the point again, come back to the footing, I click save, and get the point property. So it will show me the spring that has been assigned to this point. Okay. Um, okay, so um, now let's say I want to there's more function that you can play with. So get get point property will show you all the property that relate to the point. But let's say we want to change the spring name of this point. Of course, the coordinate is something that fixed we cannot change, but the spring name property we can change. Let me show you, because maybe this one too many points. So that's I just select few points first to show you. So for example, I select this point. I select this point and then I get a point list. Okay, and I get a point property. Now the spring of this one is 2 p 1,500. Okay, now let's say I change this one to I know I have another spring I know, so okay, this one we can maybe I will turn around a little bit, but if you think I go too fast, you can stop me. um Regarding the property, we can also go to the modeling. Let's say you want to get the spring property, then you can, if you want to get a list of the spring, you can go to modeling, and then you can get the spring property. Oh, sorry, spring property. Um, get the spring property. Oh, sorry, this one is not the spring. Uh, it doesn't show you the spring list. Sorry, this one is different function. I show you later. Let's say come back to this. If you want to change the spring of this point, you don't need to actually go to here and then you change the spring. Basically, if you have many points and you already know, let's say this one the pi doesn't work, and then you want to change to different pi. Let's say you change to 2.200, something like that, and then this spring already exists in the spring list. Then you can just set the point property. So it will already sorry, it will update, sorry, set point property. It will, okay, sorry, this one's locked, so that's why it's not update. You have to make sure that it's unlocked. I should get set point property again, and you see the spring will change. Okay, that's one example of showing you how to interact with the program. So in other words, if you go to this define, you see the first few rows of this. This is the object element, the key element, the name, the index name of the key element that the program will work with. So the program can work with point, work with beams, column, wall, slab, links, okay, something like that. And with each element here, there's some property that related to it. Um, so the concept is kind of like that. Okay, let's come back to there's many things here what can do. Maybe I continue with this point. Let me run the okay. There's a two way to interact with the programs through the element. First, you can interact with the program through the unique name. Let's say I come back to, maybe I would turn on the unique name of this. Go to the label, turn on the label. Okay. Let me clear this name first. Maybe clear this name. Clear the point group. Okay. Sorry, not. Uh, Something wrong with this function. Okay, let me change this back by hand. Okay. I duplicate join name. Okay. Let me explain this. It's quite important to understand this to work with the program. Okay. Let's say if in your model, each element, let's say beam point, it will have the unique name. if you at the beginning the etaps will give you any random unique name. Let's say this is one example. Okay, so you can you can you can get you can use this unique name. Let's say you can use this unique name to get the property just as I showed you. Okay, just as I showed you. The other way to do it, let's just say like if you want to, a lot of the time we want to do it as a group, as a group. Okay, there's two ways to assign a group in this program. Let's say you don't want to, let's say I turn on a few of the this I will try to explain. Okay, let's say you have this 3 point. Okay, at the beginning it does just give you the random name. Okay, so you can select this and you get a point. This is the random name. Okay, but let's say you want to group these three become one group. Okay, there's two ways to do it. Either you can go to you can click a new cell or anywhere here in the cell, and you try to get the name list of this. Let's say you want to get the, you select all of this and then you get a point list. So you, when you click one cell and then select all this point, it will give you the list of the point but separate by the comma. Okay, then you give this one a name. Let's say P1 or P1. Okay, then you set the point list. You click set a point list. If you have so many lists, so you can just select all of them. So let's say you have another group. Let's say you have this group, this 3 point. You select this three and then get point list, and you name it P2. Okay. Now this also understand that this one is P2, but it will not show on the screen because this one is just your definition in this Excel sheet only. Okay. And now instead of interact with the unique name, you can just show the point group. Let's say P1 and P2. Okay, now for the pointer, when you define it as a point group, this XYZ coordinate is the center of that group, is not the separate coordinate of each point anymore. It will be the center of that point group. Okay, um, and then I will prove, I will show you after you define that, this become the group. And then let's say you want to select this group, you select point. So you select point, you see, you select the group, it will select the 3 point in the group that you define. Okay, if you unlock and then you select another group, you select point, and it will this select the other point, and you see this three point. This is the first way to define a group. Okay, and then once you have group, you can also interact with that group again. So you see, it will show you that group. Oh, but and then now let's say this 3 point, you want to change it. You want to change the spring property. You want to change it. I will turn on the spring property of this 3 point. I'll show you when it turn to group is how it works. You see this 3 point is group P2, right? And previously it has a few other spring property. Now we want to change it all to this type of spring property. And then we just select this and we set property. And you see all of this change to the same spring property. Uh, that is the way to interact with the group. The first way to interact with the group. The second way is you don't want to define like this. It's fine. The second way, you don't need to do this. The second way is you can select, you can directly, sorry, you can just, you don't set police anymore. You update it to blank. And the second way is, let's say you select this and you just select the group. You just have a group read on the screen. Okay. And then you from the program you select assign point group. I select say first assign point group. So what the program There is, oh, sorry. Um, why is not happen here? Uh, okay, I'm sorry. I just show the Spring property. That's why I don't see the unique name. I can turn on the unique name again. You see, after we assign the point group like that, the program will automatically add a bracket and then add the point group to the label name. So this way you can easily to see from the program. So you want to assign with this point group again, with P2, you will assign the point group and the program will add P2. Now you can do the same to work with the point group. So you can select them. You can select them, okay, or you can get extract the data with them. It's the same like we interact previously. Okay, that so this concept is applied with all the beam element, beam columns, the same thing. You go to the beam, you see, either you will assign the group list of all the member, or you will select that and then assign the group on the screen. That's a two-way to do. The I will explain why we have two way to do it. The reason is at the beginning we want to do the design pretty fast. Okay, then we don't have time to assign the group like one by one like this. So we want to design pretty fast, and then and this type of define the group can only do when you unlock the program. That's why sometimes we already run the program. We want to get the result very quick, then you have to use the other way. You cannot assign the group on the screen like this. That's the reason we have two way to design to define the group. Uh, okay. Um, okay. Maybe play a little bit more with this footing. Let's come back to hope I haven't saved it. Okay, good. Uh, So in this, because we have limit time, so in this session, I will try to quickly introduce to you maybe three things. Let's start with foundation. Okay, that is the foundation. Maybe foundation. Let me think. Foundation. Okay, foundation. I may give you a very quick introduction only. There's more things for foundation that I will show you. But let's say we have this list already, right? You know how to define the group already. Now let's say you want to get the very quick design of foundation. Okay, so um, when we want to design the piling foundation, for example, what do we need? What we need is we need the to get the load from the pi group very fast, right? So I come back to the maybe I will open uh, one of the template that I have for, let's say I have for the um, paper house. Let's say I want to have the foundation template. To create this template, actually you can do the same thing like I just showed you. Um, and then the submission package. Sorry. Okay, foundation. Okay, piling design. Okay. Show you this. Okay. So when we do the piling design, if someone already familiar with this, you know that the piling schedule usually we will show the zone of the borehole and the pi diameter, right? So this pi diameter is maybe I open the Faber House footing to explain to you. Maybe it's easier. Show Faber House footing. Okay. So usually we will try to when we do the piling design, we will not like every pi we will not show it name by name, but instead we will try to group the pi, right? Let's say we for all of this pi, we group it as we name it like borehole 1 and 1.2 diameter pi, something like that. So you will present it in this piling schedule like this. So you plot the zone of the borehole and the pi diameter, right? And in the next thing is you will plot the DA11, DA12, and the working stress, and then next is the capacity, and of course the URs, things like that. Okay, this is one of the example. Okay, now I would this capacity is actually from your piling calculation is from Geo will give you, but the structure you need to give Geo this one. Okay. Um, so by using the group function that I just showed you, you already know how to group this pi. Let's say you group all of this pi. I will come back to the label. I will show you. Okay. So let's say we already group this pi, right? We group this and by using that function, and you see after you group it, it will show the bracket and then the name of the group in front of this name of the pi that I just showed in each group. So you know that this pi is belong to this 1P600 groups, and this is all the group that we have. The group name is here. You see the group name is here. Okay. Now in after you run your result, sorry, I try to run here. I don't know whether sorry, it takes few minutes. Oh, okay, this is safer, so it's pretty fast. So the main thing is after you run your result, you need to get the axial force of all of this load column as fast as possible, and you need to get the maximum. So the program will allow you to do that in the quickest way. So you go to the footing, right? So you have your name of your group here. You already assigned in the previous step. Uh, and next thing you do is you will create this row. For forget about this row. It's just that you need, and then forget about this one. Okay, you need to have the index. I will do it again. So I will create this. So this name is the name of exact name of the load column that you want to get the result. Okay. Then what you do is you have this name list. I'm sorry. I should not run design strip lah. Maybe wait me maybe wait few seconds. I present it. After I present it, um I will move to the beam design. Yeah. Maybe I should cancel the. I mean, okay. Okay, I just click cancel. Okay, good. So after we run it, right? You see the still keep designing. Okay, maybe when during it design. Okay, it's done already. Uh, it's still processing. Yeah, should not click design. Okay, so it run already. So after it finished running, you see you can get so you look at the load combo. This is the load combo that you want to get. This one is actually the envelope combo. Okay, we have our group design already. So what we need to do is we just need to okay. I want to remind you this one is the point, right? This one come from the point name in index, right? You should have this row in your. Maybe I just hide this first. So this row is the index row. So you see you have the point, which is the key index name that you have. Okay, then this is the list of the load that you want to get. Once you have this row already, basically you just select all of the pi group and you go back to the footing, click save before you run, and then you just get the maximum reaction. Okay, so it will give you the maximum reaction of 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 all of this load combo. Okay, maybe I present this one. So this one is put under template already, but let's say you want to create your own templates, what you do. So I will come back and remind you. So like you can just click this, you can create a point, right? And then you go to here. Sorry, that load com is not show here. So basically you have to get the load com from let's say you can click get combo list, right? It will give you the combo list. Uh, the load you want to get is this one. Is maybe this two envelope BC. You have to copy here, copy in the transpose. So you need to get these two, and then the SLS, right? The working load. So this is the way you can create your own template in your own way. Okay. Um, okay. Again, similar to that, you can. Okay, the quick way to get once you name all of your group or already, so you can select all of your point, and you can go to back to the footing, and then you get group list. It will give you the group list. Okay, and you don't need to select this one. This row. Basically, you go back to the footing and you click save and get the maximum load. It's the same thing, right? It's the same thing to get the data from the programs. Um, let's say this one it gives you the maximum compression load, but if you want to get the tension load from this load action from this, the tension load basically is the minimum load for each of the load case. You want to get the tension load for this. You will what you do is you have to do the hand count. You have to use this one, and you type in uh, n, and if I'm remember not wrong, you put tens. Yeah, sorry, bracket and tens, and then you use the same format. Okay, click save and select again and get the mean reaction. Sorry, a concept like that, but maybe this keyword I typed it wrongly. Uh, Anything wrong? Let me check back this one, but is the way, but only I don't remember exactly what is the keyword. Okay, but that's the way. Another way is sometimes if you want to do this one is for the piling schedule. Okay, another times if you want to do, let's say you want to do some anchor ball design for the column direction. So you don't need to, you have to get more of the result, let's say the moment and the axial load. If you want to get that, you have to go to the you see, you go to this list, it say maximum axial force of point reaction, minimum axial force. This is shear force, and then the moment in XYZ. So you pull out this list, and you go index design assign, and you save, and you select the list again, and you will get now you go click this button, and then you will get the envelope. It will give you the envelope of your maximum force, compression force, minimum force, minimum axial force, maximum shear force in both way, and maximum moment if it have. Um, okay, that is the shear property, the, um, the point. Uh, okay, this okay. I will move to the next section. Is design the beams. Uh, Let me open one of the beam design. Okay, I will use this unlock try to explain the beam design first. But first, let me open. So to do the beam design, first you need to have a beam design template. So to get a template, you will click to this design, and you will pull out this design beam template. Let's say you want to design, you want to do the beam design, right? And then you will from this you grab it to your folder, okay? And then you double click. Okay, and you double click, and when you double click, you will be able to open a design template. Okay, so this design template will contains the beam schedule and the tab for beam checking, and one of the define tab. I will explain next how we're gonna use this define tab. So the beam schedule you already familiar with. So I just delete this first one. But in the beam schedule, I add one more two more columns. This column will basically define what type of beams that you are looking that you are designing. So let's start with putting NA for everything. Let's come back to the define and come back to the plan. No, now let me repeat again. Let me open the unique name and show you the unique name first. Uh, okay. Maybe I show too much thing. Okay. Okay. You pay attention here. Here in this file, I already defined the beam group. Okay. You can name the beam. But let me. So the same as a pointer. So basically, there's a two way you can group the beams. So either you can just select the beam, and you go to the so you go to the tools, you go back to the tools, and you go to the beam here, and you can get the beam. You can get the beam list. I said you can get the beam list. This two beam, and you can get the beam list. Okay. Oh, sorry. I have to. So to work with ETABS, I have to click this button and then come back to ETABS again. And I have to make sure that this one is the window, the active window. So I go to Tools, I set as active window. Okay, now you want to get this two beam. You get the click save, and then you get the beam list. So it will give you the beam list. You want to select this two beam, and you click here and then get the beam list. And now you can actually name the group. Let's say you name B1 and B2. So, and then you set the member. This is one way to get the group. Okay. Of course, the other way, which already show in in this um, in this plan, that I already assign the beam name accordingly. Okay. Um, because this one using the old program, so the beam name is actually in the bracket, in the circle bracket. But to work with the old version, but it's actually in the new version, you don't need to do it anymore. But because I have to work with this old version, so I change the I change the bracket into the same bracket, so I can be able to work with it. So now, let's say you want, after you already finish naming all of the group, okay. Um, Now you want to do the design. Maybe I will open one file I already run. Uh, Hopefully this one I already run. Yeah, this one already run. Now you have this already, and now you want to do the design of this two beam. The first thing you need to do is you need to pull out the load combination that you want to do the design. You get a combo list. It will give you the combo list. Let's say your beam design, you just want to design with all of the B set load com. Okay, then you just keep the B set load com, and you have to get the output, set the output combo as this all of the load com here. Okay, if I'm not wrong, in this one I have to get the ULS as well because this one is only one floor. I have to get the ULS, otherwise it will not show anything. Okay, I set the output combo again. This first thing you need to do, you have to set the output combo to get the result. So once I do this and I have the beam group already, so this one I will delete everything. Delete every information here first. So I will straight away go to show you the design step. So once you have you define a load com, and now you want to design this beam. Um, Actually, you can design all the beam. If you name it already, you can design all the beam at the same time. Let's say SS T. I will select all the beam now. Okay. You use the same function. You can select all of them, and you will select. You go to the beams. I say first, and then you say get the group list. Okay, so it will give you the group list of all the beam that you select. Of course, because this is the group list, so remember that you can, for these two beam, for example, you can group it in the same group. You don't. So in this case, because we use group for each beam separately, but in case you have many beams that similar, you can actually group them using the same name. Okay, so once you have this list already, uh, then uh, you have to copy this one, or you have to copy this one to the beam schedule. Of course, the name of the beam schedule and that one you should have the same list. Okay, and what you do is you can assign first. If you don't know which one is the type of the beam first, you can just assign some type first. Let's say simply supported, something like that. And now you start to do the design. Unless this one is not quite automatic one, so you have to maybe design one by one. It's be better because the way it do is you have to go to each beam and design the reinforcement first. Let's say you design. Uh, okay, you can repeat with many beams, but maybe let me select this two beam to design first to because I want to show you the meaning of the result. Um, I go back to this and then I select this two beam only. Okay, and um, I will select get group list. Okay, the same thing. I will select get group list. Also give me the same thing. Okay. Um, Once you have the group already, the first you need to what you need to do is you need to um sorry what I forgot already. Okay, you need to go to the design and you have to click this sheets assign. Okay, and you have to select all of the beams. Basically, if you have so many beams, you have to cover all of this. Okay, this one will help the program understand where is your beam schedule you want to get the information from. Okay, and then we'll once you have the group name, you see there's some property here. So I have some property here. Where this property I get from, this one I already put in a template, but if you want to have a new template, remember you always go to this define, and you see I have the beam keyword beam here, right? I have keyword beam here, and I have keyword section here, right? This is section I put here, with depth, math, okay, every information here, and then MT1, MT2. This is you can see the meaning of the beams here. Max MT1 mean that maximum top moment at the beginning of the beam. MT2. So for the beam design, we basically deal with three sections. 1, 2, 3. One is first end, three is last end, and then two is the middle end. So MT mean top moment, and then MB is bottom moment, and V1, 2, 3 is the shear. Once you have you show the beam group here already. So you go back to the beam because here we are dealing with the beams. We can start getting some properties of this beam. You get the section, and it will show you the uh, the section of the beam that you show in ETABS. Okay. Okay. Then here, if you click to the same button, it will show you the same. So you can fill in you can see it show you the actually I this one. Okay, it will show you the span of this beam, and it will show you the width and depth of this beam. Okay. um and then once you do this, we start to key in some of the reinforcement. Okay, and sorry, we don't key in here first. We go back here, and then we just click get the force resolve. Remember, we already defined the load combination. If we don't define the load combination at this step, uh, yeah, we if we don't define the set output combo, when you get the force, it will not show you anything. But if you already define, and you go to here, and then you will say get the force result. So the force result, it will give you the maximum force at that section. So I will show you. Let's say this beam we are looking for, right? Um, okay, and then okay, this is very interesting. Okay, let's say we don't select this beam at the beginning, since we have so many beams already. Let's say if you want to check this force whether it's correct or not, what we do is, now we remember we don't have any selection, right? So you select this two beam, okay, and then you click select beams, okay. Then it will select these two beam for you. So that's the way you can select many beams from. So and then here you can click the show the moment, and you can see that um, it already show the maximum moment in, let's say, this beam. It showed the maximum at this section. MT2, of course, the negative moment, you don't have anything, and MT3, yes, you have some moment here. Right? And MB1, you also don't have anything, but MB2 is the maximum positive moment. So the V also is show you the shear at each section. So now to continue with the design, you will go back to the beam schedule, and then you give some reinforcement. Just estimate, let's say you put 2H25 for each section, and then you can copy. Okay, sorry, 2H25. You can start with any reinforcement, base reinforcement that you want. So the bottom also, and the stirrup also, you put a H10 at 200 for this beam, for example. Okay, this is the first thing. And remember, this one is simply supported, so you have to key in the reinforcement here, right? If it's continuous, if you key in the reinforcement here, the first end you have to key in first end span. The second one, if you key in the reinforcement here, you have to select inter span 1 and then inter span 2 accordingly. Otherwise, the program will not recognize. If you key reinforcement here and then select a different type, the program will not recognize it. So once you key in the reinforcement already, you come back here. And you just select this two beam again, and you can just go to here, and you select perform design. Oh, sorry. So you see what it does is it will perform the design. First, it will get the reinforcement from what you input, and then it will perform the design. So the design is something linked with this calculation here, but this session I will not talking about it. But let me explain about this design. So you see it will show you the design check, the flexure check for each section: MT1, MT2, MT3, MB1, MB2, MB3, and then the shear section here. And then also it will show you the crack check for top section 1, top section 3, and then bottom section 2. Okay, so look at this look at this result. You will see in the bracket, it will show you the percentage of the reinforcement. Okay, and then the first ratio, it will show you the utilization ratio, like compare with the demand with the capacity. Now is exceed 8 times. Okay, so from here you can quickly know for example this section, you have to increase your reinforcement to 8 times. So to quickly revise it, we come back to this, and then let's say we change to 10H32, and then we come back here. We come back here and we select this again. Okay, the same thing, and then we select perform design. You see this one, it will update this to 10H32, and it tell you that the percentage now it go up to 0.8%, and the UR is 0.99. Okay, so this symbol like that is the way you design. Um, the program is also the one that I just showed you is just the manual design. It means that it's based on the spreadsheet here. Okay, but in case you want to make sure that your design also tally with ETABS, then you click. You have to set up the design in ETABS, and then you click ETABS design. So you click design in ETABS. Just wait a little bit so that the ETABS can do the design, and then the design from ETABS also gives you some reinforcement for each beam. All right. So basically, after you finish running the design in ETABS, you come back to the spreadsheet and you get the design from ETABS. So you can have two results to compare. First is the design from the manual, and the second is the design from ETABS. So the program can also collect the design, the reinforcement design from ETABS to make sure that if not sure about the manual calculation, then you can also use the design from ETABS to double check that. Okay, sorry, take a few more seconds. Okay, so, after you run the design, so each beam have come up with some reinforcement already. Now you go back to the program, and you see here we have some reinforcement. So we have two zone of reinforcement. This one is this zone with start with AS1 is from the manual calculation. Okay, this one without one is from ETABS calculation. So to get the redesign from ETABS calculation, you just select these two beam again, and then come back to the beams, and then you click save first, and then you get the design result. You see, it will get the design from the reinforcement from ETABS. So and the reinforcement it check here is the envelope of both ETABS and safety. You see the ETABS will give you a little bit more reinforcement. That's why it show fail again. So here you come back and increase reinforcement. The program is designed for any kind of adding reinforcement as you want. You can either put in one row like one number like this, or if you want to add the reinforcement, let's say for H32, something like this, the program also understand it and perform check. You see, it will show you that it's 432 is added, and the reinforcement increased to 1.09, and then the UR is 74. And then you can also check the crack width. Usually, if you follow the code, and then if the capacity is okay, and the crack width show you is less than 0.3, so it's also okay. The crack width is 0.2 mm. Okay. So I will show you the one more thing. Like previously, we work with this beam, right? We work with this beam. Let's say we are working with this beam. This is 3B21, 3B20. Let's say 3B20. Will work with 3B20 first. And then sorry, I select this beam. Come back and select this beam. Target the beam group. Oh, sorry. I should get the group list. Okay, I get this beam, and then I come back and get this beam. The reason I want to show you is this two beam is continuous beam, right? This two beam is continuous beam. So what we do is the first beam we assign it as the first span, the first end span, and the second one we will assign it as interior end span. So for this one we have to move to here to input as our company's format. So we will put some maybe to IH, so 10 is 32. We also input the reinforcement as per our company's format, something like this. So this one is the reinforcement for this continuous beam, right? And so this one is the reinforcement at the second section. This one is continuous beam. So the first section it will get the reinforcement from this one. Okay, so I will come back to this, and I will just copy this name here so that it be equivalent, and then come back to the design. And now let's clear the design first, and also clear this one. And now I will perform the design check. So as you can see, now it will also read the reinforcement from the previous beam. You see the first section is similar to this section, this three section of previous beam is similar. So if I change this one to 2, and I come back here and I perform the design check, you can see both section is updated accordingly, and it always should tell you which is fail, and you can read here and then increase your reinforcement accordingly in the beam schedule, and you can see the checking if it's all green, that and it will be good. Okay, one last thing for beam design I want to tell is in sometimes with EDAPs we have an issue that okay, we have issue like this case. Okay, I turn on the image. You see, so we have to sometimes we have issue that we have to mesh one beam into so many beams like this. So this one is considered one beam, but because of the meshing problem, we have to mesh it income two beams so that this have sharing the same node with this. So to deal with that, we will try to put this symbol. I don't know what's the name of this. So this symbol at the end of the name. So let's say this one is 1 and this one is 2. Okay. So we put this symbol and then in the beam schedule we basically just need to write this group. The program will understand that this one is 2 beam, is 1 beam. Okay. So this symbol is applied in the case you this type group. I mean that you add this group in front of the beam name. If you use the other way, let's say you have this two beam. Okay, come back to this EDAPS. Let's say you have this two beam. Let's say you have this beam and this beam. Okay, and you assign in a different way. You assign you get this beam. You assign the beam name here. Okay, and now you put this one as B1. Okay, you use this way to assign your beam group. Then these two, if you want to consider it as if you put the semicolon like this, it will understand that's two separate beam. But if you in this list, if you want to this two beam as a one beam, you just replace this one with this plus. It will understand this one is one beam. Same thing with another way. If you have the beam is made up by 3 or 4 beam, you will add them together. It will become one beams. means that your list will become, you have so many beam in the list. So come back to this program. You have so many beam in the list. So you end up with, you have to add like this. So once you do this, and let's say you come back to this beam, I will get this beam, get the group list. Okay, so and get the section. Okay, the reason when you combine the beams like this, let's say this beam you have this moment diagram like this, right? Okay, so since it is one beam, it will consider the maximum moment at here, because if you just assign it as this beam, it will consider the maximum moment of the section 2 is here. But if this one, all of these are one beam, and then when you get the force result, it will read the maximum moment correctly. You see, 4 is here, and the MT3 it read this section. So that's the point of this. I think we only have time to cover the beams up to the beam so far. Maybe we will try another session for the column design. But so far that's the beam design. Everyone, if I'm going too fast, or is this okay? That's done for the beam session. I think we will try to do the column session at other times, because everybody need to go lunch, right? Or you want to continue? I mean,
Nobody responded.
nobody
I think we go for lunch. Yeah.
Yeah.
Anyway,
Maybe go for
let's
lunch.
everyone
Um,
digest.
Ken, I think thanks very much for your arrangement. I think
Yeah.
to benefit from this section, right? Can I suggest, if let's say everyone seen or install the program, can we have maybe hands-on? Everyone can try on the spot by their own PC next time. Maybe can enhance the memory. Yeah. Actually, I a bit lost. Also I have tried halfway, so a bit lost. So maybe I thinking, if let's say we hands-on follow the step you mentioned, then we also click on ourselves. Maybe can deepen the memory. Yeah.
Yeah. I think this one is recorded, so you can listen to the for
Record,
the
right?
begin part. Yeah.
Okay. Thank you.
Okay. Yeah.
So when is the
Okay,
next one?
Next one maybe tomorrow or
Wow.
anytime.
Okay. Wow. Okay. Tomorrow is Friday, right?
Yeah.
I'm actually
Okay.
Friday. I'm fine. Okay.
We can do something very quick now. Yeah.
So for what time tomorrow? 12.
Yeah. So lunchtime, if everybody okay, we can do 12 also.
Okay. The rest okay?
Okay.
Wow.
Yeah.
Okay. We got thumbs up already. Okay. Can.
Oh, yeah,
Okay.
forgot. Yeah. So okay. Tomorrow we will cover more things. Yeah. So
Okay. Thank
basically I
you.
want to show the beam column design, and then there's a few more things for maybe the complex geometries, and maybe transfer the how to do the connection between ETAPs and safe, something that I'll try to cover. Yeah.
Yeah.
Sure.
Okay.
Okay. Thank you.
Thank you.